Hello everyone. In this video, we will talk about READi-Dem, a machine learning-powered web interface tool designed for the robust, efficient, and affordable diagnosis of dementia. I am presenting this on behalf of my colleagues, all of whom are members of the DEMEN Network, an international organization dedicated to the application of data science and AI in the field of dementia. With an aging population, the prevalence of dementia is increasing. Current dementia screenings involve a combination of medical history, questionnaires, and cognitive testing. While these methods are quick to administer, they usually require the presence of a medical professional or psychologist. This is especially problematic for low-resource countries like India, which have a low doctor-to-patient ratio, a significant portion of the population living below the poverty line, and unable to afford even basic healthcare. In this work, we explored the question of how to minimize screening costs. First, we identified the most predictive features of dementia that are both concise and cost-effective to obtain. Subsequently, we developed a prototype web application to implement a machine learning model for dementia prediction. We utilized the dataset from the longitudinal aging study in India, READi-Dem. The participants were aged 60 and above, with a deliberate oversampling of those at risk. They resided in 18 out of 28 Indian states and encompassed a substantial rural population. The majority of participants had not completed secondary education. As part of the study, a large battery of cognitive tests was administered, including the Hindi version of the MMSE, HMSE, along with informant reports and a comprehensive geriatric assessment. In total, there were over 648 features. Based on a compilation of all these measures, clinicians assigned each patient a clinical dementia rating, CDR, which encompasses 5 stages of severity. The following histogram illustrates the distribution of the ratings. Since there were relatively few patients in the more severe categories, we dichotomized the outcome into dementia and non-dementia. Next, we identified the features that exhibited the highest predictiveness for the binary outcome, initially starting with the full feature set. To achieve this, we employed the Boruta algorithm, which involves creating a duplicate dataset and randomly permuting the values within each feature or column. This process can be likened to establishing a null distribution. Subsequently, the algorithm evaluates whether the original feature's predictive capability for the outcome surpasses that of the randomly permuted copy. This algorithm enabled us to reduce the feature set to 41 features. Upon examining the correlation matrix among the selected features, we noticed that they could be categorized into 2 distinct domains. You can observe these divisions in the 2 prominent clusters depicted here. The first cluster comprises informant measures, which encompass questionnaires related to daily living. The second cluster comprises cognitive functioning variables, which include factor analysis scores derived from various domains that can be time-consuming to acquire. Given the apparent presence of latent factors, we proceeded to reduce the number of features using principal component analysis, PCA, a technique that identifies components explaining the most variance in the data. In our particular case, the first 2 components accounted for 85% of the variance. As demonstrated, the dementia and non-dementia groups were clearly positioned on a 2-dimensional plane. This suggests that a straightforward linear separator could effectively distinguish between them. More significantly, the space was effectively represented by 2 vectors comprising the HMSE and TICS, the telephone interview for cognitive status, along with the IQ-CODE. This implies that groups could potentially be effectively differentiated using only 27 items in total. These 27 items consist of straightforward questions. The first 10 questions from the HMSE, 1 question from the TICS, all items from IQ code. We then aim to assess the performance of the minimal feature set in comparison to the more complex feature set. For this purpose, we trained 6 standard machine learning models on the optimal feature set, which included 41 features computed from over 200 individual items, and compared their performance to models trained on the minimal feature set containing only 27 items. Our primary concern was whether we would compromise accuracy by reducing the number of features. Now, let's examine the results. I will present the model performances for both the optimal feature set and the minimal feature set, which you can see on the x-axis. The y-axis represents the performance metrics, and the colors correspond to different machine learning models. All models achieve approximately 90% accuracy for cross-validation with the optimal features, with the support vector machine performing the best. In comparison, the minimal model performs only slightly less effectively. When examining other performance metrics such as accuracy, sensitivity, and specificity, we see a similar trend. This indicates that the minimal model is adequate for predicting the outcome while utilizing significantly fewer features. Therefore, we integrated the best performing model into our web platform. This platform allows for the collection of relevant scores from the patient and caregiver, and the model then provides a prediction. You can access the web platform at https://www.researchmind.co.uk/READi-Dem. On the right-hand side, you'll find instructions, and on the left-hand side, you can input the relevant data for a new patient. This includes the MMSE and the IQCODE. There's also an option to export the collected items and obtain the model prediction for the patient. In summary, I've demonstrated that the minimal feature set we've identified is effective in predicting dementia, regardless of its subtype. Importantly, these features do not necessitate face-to-face testing and do not involve tasks like clock drawing or word recall. Only 11 questions for the patient and 16 for the caregiver are required. Since this approach is based on the Clinical Dementia Rating, CDR, it remains consistent with clinical intuition. The brevity of this screening makes it well suited for use with large populations, and it's further facilitated by our adaptable web platform, which can be accessed via smartphones. We anticipate that low-resource countries, in particular, may benefit from this approach. Moreover, we have reason to believe that the same minimal feature set can be applied in other cultural contexts. We trained and tested models on the American Hours Adams dataset in the United States, and achieved similar levels of accuracy. Thank you for your attention, and I want to express my gratitude to this incredible team for our collaboration. I'd like to briefly mention that we first connected during the online NeuroHack hackathon organized by the Demon Network UK in January 2022. It was a fantastic experience, so if you're interested, I encourage you to explore the network further. Thanks for watching.